Hello everyone. In a short video, I would like to explain how we can calculate the oxidation number of the metal cation and then write the electron configuration for the cation in noble gas notation. Let's see compounds one by one. First, vanadium pentoxide V2O5. Vanadium pentoxide metal is vanadium. The oxidation number of the vanadium. Oxygen is -2 is the oxidation number. So if we apply the equation, there are 2 vanadium atoms plus 1 oxygen is -2 times 5 oxygen atoms. This should be equal to 0. The meaning is V2O5, the compound is neutral, no charge. Therefore, we have to equalize the sum of the individual oxidation numbers to the 0. And then you can calculate the unknown oxidation number, that is oxidation number on vanadium metal is +5. If we write the electron configuration of neutral vanadium. Neutral vanadium noble gas electron configuration is argon 4s2 3d3. But vanadium +5 is the oxidation state in this compound. So we need to remove electrons from outermost shell to the inwards. When we fill the electrons, first 4s and then 3d. The reason is 4s is in lower energy than 3d. However, when we are removing electrons, we need to remove from outer shell, that is n number larger shell first and then the lower shells. So here first we need to remove 4s electrons and then come to the 3d. So after remove all 5 electrons, 4s2 and 3d3, the vanadium +5 configuration is equal to argon configuration. Next compound, KMnO4. This is potassium permanganate. In potassium, there are 2 metals, potassium and manganese. But let's calculate the oxidation number on manganese. Let's apply the same thing, same equation. Potassium is in group 1, therefore +1 charge. Plus manganese charge we need to calculate, plus oxygen charge is -2, but there are 4 oxygens. So this is a neutral compound again, so we can equalize to 0. Manganese in the +7 oxidation state. Manganese atomic number is 25. So if we write the neutral manganese configuration, it is argon 4s2 3d5. What is manganese +7? Remove 7 electrons starting from the outermost shell. Then manganese 7 configuration again equal to argon configuration. Third compound, K2Cr2O7, potassium dichromate. We are going to calculate oxidation number on chromium. The same way the compound is neutral, 2 times +1. Potassium is +1, there are 2 potassium ions plus 2 chromium ions plus 1 oxygen is -2, there are 7 oxygen atoms. So 7 times -2 is equal 0. Sum of the individual charges, oxidation numbers should be equal to 0. Now chromium is +6 oxidation state in this compound. Chromium atomic number is 24. So if we write the neutral chromium configuration, it is argon 4s1 3d5. Or if you want, you can write 4s2 3d4. But here we learned another concept, the anomalous behavior of the configurations in chromium and the copper. So partially filled and the completely filled configuration writing is more stable than D4 and D9 configurations in chromium and the copper. So what is chromium +6? We need to remove 6 electrons starting from outermost shell, the n number larger shell. Then chromium +6 is again argon configuration. Next, Fe2O3, ferric oxide, or in systematic way you can name iron 3 oxide. Oxidation number on Fe. Fe2O3 again a neutral compound, so we can write the equation. The iron charge times 2 plus -2 is 1 oxygen atoms, there are 3 oxygens, is equal 0. So 1 iron charge is +3. Iron atomic number is 26. If we write the neutral Fe configuration, it is argon 4s2 3d6. Now what is iron 3+? Remove 3 electrons from outer shell, starting from the outermost shell. So here outer shell is n is equal 4, not 3. N number larger shell. So first remove 2 electrons, 4s2 electrons, and then remove another electron from 3d6. Then Fe3 plus configuration is argon 3d5. Cuprous chloride or copper 2 chloride. Again CuCl2 oxidation number. We can calculate equalizing to 0. Copper is +2. The neutral copper electron configuration is argon 4s1 3d10. Like chromium, you can write 4s1 3d10 instead of 4s2 3d9. Another anomalous behavior of the configuration, because completely filled electrons in 3d level is more stable than 3d9. So what is copper 2+? Starting outermost shell, that is n is equal 4 shell, we need to remove 2 electrons. One 4s1 electron and another from 3d10. Then the copper 2+ configuration become argon 3d9. Next one, HgBr2. HgBr2 mercury 2 bromide. We calculate mercury oxidation number, it is +2. Mercury atomic number is 80. So if we write the configuration in the noble gas shortcut, xenon 4f14, 5d10 and 6s2. Hg2+ meaning is outermost shell, that is n number larger, 6s2 electrons we need to remove. Then the configuration of Hg2+ become xenon 4f14, 5d10. I hope now you will understand how to calculate the oxidation number on the metal cation in the given compound, and how we can write the metal cation electron configuration in the noble gas notation.